Hi guys, welcome back to my YouTube channel. Let's crack real math. My name is Viraaj, and in this video we're going to have a look at stationary points, second derivative, and maximum/minimum points. So greetings of the new year to everybody, and without further ado, let us begin. So before I start explaining, if you're not comfortable with differentiation, or you're not sure what differentiation is, I would advise you to watch my previous video under this playlist on the basics of differentiation, because that is going to be the key foundation of this video. You need to know how to differentiate in order to comply with this video. So let's begin. We have something named or called as stationary point. Stationary slash turning, that's another synonym of it. Turning, or another one is critical. So stationary point, turning point, critical point. These three all mean the same thing. The question arises, what? In a non-linear graph, that is any graph that's not a straight line, there's always going to be a turning point. Let's take a quadratic graph, for example. A quadratic graph could either be something like this, or it could be something like this. Now, where is the turning point? The turning point is simply, or the stationary point, or the critical point, is simply where the tangent at that point of the curve is 0. In this case, it's somewhere here. So this point here, maybe. Of course, not accurate, it's just a rough sketch. And somewhere here, this point maybe. And at stationary point, we say that our dy dx is equal to 0, because as you know, dy dx is simply the gradient function of a graph, and the gradient at this point here or at this point here is 0. Now, of course, in a quadratic graph, there's only one turning point. If it's, for example, let's say a cubic graph, something maybe like this. Just extend this, yep, something like this maybe. Then you can see you have two turning points. You have one over here, where dy dx is equal to 0, and you have one over here, where dy dx is equal to 0. Now, when you have two turning points, or even in any question that has a single turning point, they can ask you to ask whether it is a maximum or a minimum. Now, before I enter maximum or minimum, before that, in order to get to maximum minimum, you need to know the second derivative, which is d square y over dx square. And what you do in your second derivative is that you simply differentiate your dy dx. Suppose your dy dx is 4x squared. If you differentiate that, your second derivative would be 8x. So that's just an example. Now, for your maximum or minimum, if your d square y dx square, if this answer, or whatever you get for d square y dx square, is greater than 0, then it is a minimum point. And likewise, if it is, or conversely rather, if it is less than 0, then it's a maximum. So you can sort of remember it as the opposite, that if the values are less than 0, it's actually a minimum, and if the values are greater than 0, it's actually minimum, and if the values are less than 0, it's actually maximum. Now, how would you get a value? Most of the times, your d square y dx squared would be something like this. Let's say 3x, or maybe 5x squared. And what you would do is that in your place of x's over here, whichever expression you can take as an example, you would substitute the x coordinate of the stationary point. So let's say this stationary point here, for example, is 2, -1, just an example. You would substitute this 2 over here. And doing that, we know that that would be 5 times 4, because 2 squared is 4, and 5 times 4 is 20, and hence, in this example, this would be a minimum point. 2 comma minus 1 would be a minimum point, because its second derivative, when inserted as x, is giving you a value of greater than 0. So that's the basic foundation of the knowledge on stationary point, turning point, critical points, all the same thing, second derivative, and maximum or minimum. So let's head into our first example. Right. It says, given that y is equal to 1 over 3x cubed minus 9x, find dy dx. That's the I part of the question. So, okay. Let's go ahead and do that part I. Now, it says given that y is equal to 1 over 3x cubed minus 9x, find dy dx. So we know that dy dx, I will rush a bit here because all the differentiation steps is explained deeply in my previous video on basics of differentiation. So once it comes to differentiation, you would know exactly what I'm doing here. This would be x squared minus 9, because 3 times 1 over 3 is 1, and take away 1 from the power leaves x squared, and then over here would just be minus 9. So our dy dx is x squared minus 9. That's done. The I part says find the coordinates of the stationary points on the curve y equals to 1 over 3x cubed minus 9x. So it's the same curve we're dealing with, and it asks us to find the stationary points. Now, when you need to find the stationary points, as I said, we say dy dx is equal to 0. dy dx is equal to 0. And in this case, our dy dx is x squared minus 9. So, x squared minus 9 equals 0. Solving for x, we have x squared is equal to positive 9. X is plus minus root of 9. Remember the plus and minus, that's always compulsory in front of square root, and x is equal to plus minus 3. So we have two x values. We have positive 3 and negative 3. Now if you go back to the question, if you pay attention, it said find the coordinates of the stationary points. You see it's plural in both cases. That means there are 2 points. And in order to get the y coordinates of those two, of positive 3 and minus 3 as the x, we substitute the value back into our original equation, which is not x squared minus 9x, but it's this 1 over 3x cubed minus 9x. That's our original equation, and that's where we substitute it back. So let's say when x is equal to 3, and then we have when x is equal to minus 3. So when x is equal to 3, y is equal to 1 over 3 into 3 cubed minus 9, 3 cubed minus 9 into 3. This is y is equal to, this cancels out, okay, 9 minus 27. And that is y equals to minus 18 when x is 3. When x is minus 3, it will be y equals to 1 over 3 into minus 3 cubed minus 9 into minus 3. Y equals to minus 9 plus 27, because the minus and the minus come together and make it a plus. And doing this would be y is equal to 18. So when x is minus 3, y is 18, and hence the two stationary or critical or turning points are 3 comma minus 18 and minus 3 comma 18. Those are your two stationary points. Again, doing a quick recap, you do dy dx is equal to 0, you solve for your x, you get the values for x, whether it's 1 or 2 or 3, put that x value back into the original y, or into the original equation of the curve, sorry, not dy dx. A lot of students make the mistake of putting it back into dy dx. That is not how it works. You need to put it back into the original equation, and then get your subsequent y values and put them together as coordinates. So for the II part, it says determine whether each stationary point is a maximum point or a minimum point. So we have 2 points, that's 3, minus 18 and minus 3, 18. Now we need to, they're asking us to determine whether it's maximum or minimum, whether this one is maximum or minimum, or whether this one is maximum or minimum. First things first, we need to get our second derivative, d square y dx square, and this means that we have to differentiate our dy dx. Our dy dx is x squared minus 9, so our d square y dx squared would be 2x. Now all we have to do is simply take our x values and put them into our second derivative. So when we say, let's say when x is 3, when x is equal to 3, we have d square y dx squared to be 2 into 3, which would give you 6. And when x is equal to minus 3, we have d square y dx squared, d square y dx squared there equals to 2 into minus 3, and this would give you minus 6. And remember, as I said, if it's greater than 0, it's a minimum point. So this point here is a minimum. And when I say this point, I don't mean that 6 is a minimum. No, the coordinate 3, minus 18 is minimum, because that's the x value we inserted. So let me just write 3, minus 18 is minimum, and then this here is a maximum because it's minus 6 is less than 0. So minus 3, 18 is maximum. And that's the answer to that question. Again, don't say that 6 is minimum or minus 6 is maximum. No, it's the x value, that coordinates that you put in. So state the whole full coordinates just to always be on the safe side. So on to the next example. Okay, this one says find the coordinates of the stationary points of the curve y equals to 27 plus 9x minus 3x squared minus x cubed. That's the I part. So let's go right ahead and do this. This may be a bit technical, but try your best to stay along with me. So we have y equals to 27 plus 9x minus 3x squared minus x cubed. Getting our dy dx, because in order to get our stationary points we need to know our dy dx. Our dy dx is minus 3x squared minus 6x plus 9. Now I just rearranged it. Instead of saying 9 minus 6x minus 3x squared, I just put the minus 3x squared in front. But yeah, you know, differentiating minus x cubed, you do 3 times minus 1, that gives you minus 3. Take away 1 from the power, that's 3 minus 2, gives you squared. Differentiating minus 3x squared, 2 times minus 3 gives you minus 6. Take away 1 from the power, gives you x. And differentiating 9x would give you 9. Now to get our stationary points, we need to equate this to 0. So minus 3x squared minus 6x plus 9 equals to 0. I'll take everything to the other side so I can have a positive x squared coefficient. So 3x squared plus 6x minus 9 equals to 0. So we can solve this by factorization method. We can divide everything by 3 first, so that would be x squared plus 2x minus 3 equals 0. Again, if you're not comfortable solving quadratic equations, you can watch my previous video on solving quadratic equations by factorization, and also by using the formula or completing the square. Factorizing this, I have x into, oh wait, no, x, okay, x squared plus 3x, not 2x, sorry, plus 3x minus x minus 3 equals 0. Yep, x into x plus 3 minus 1 into x plus 3 equals 0, I have x plus 3 bracket x minus 1 equals 0. The two values for x I have is x is 1, or let's say and rather, and x is minus 3. Sorry. Now that I have my two x values, I need to get my two corresponding y values. So in a way, this is my x coordinates of my turning point, and I need to get the y coordinates. And as I said, I will now substitute these two x values back into the original equation of y, which is this over here. So let's divide this in half. Let's say when x is equal to 1, we have y equal to 27 plus 9 into 1 minus 3 into 1 squared minus 1 cube. This is y equals to 27 plus 9 minus 3 minus 1, and that should be 32. So when x is 1, y is 32. Now let's say when x is minus 3, y equals to 27 plus 9 into minus 3 and 3 to minus 3 squared minus 3 cubed. Bunch of minuses there. So this would be y is equal to 27 minus 27 minus 3 squared would give you positive 9 times minus 3 again would give you another minus 27, and minus 3 cube would give you plus 27, but would give you minus 27, but 2 minuses over here would give you plus 27, so this would be plus 27 again, and this can cancel and this can cancel, so our y is 0. So when x is equal to minus 3, our y is 0. So our two coordinates, two turning points, are 1, 32 and minus 3, 0. Those are our two stationary / critical / turning points. And next part of the question says determine in each case whether the stationary point is a maximum or minimum point. So again, for our maximum minimum point, the first thing we need to get is our second derivative, that's d square y over dx square, or dy dx, if I'm not wrong, was minus 3x squared, okay, minus 3x squared minus 6x plus 9. So d square y over dx squared should be minus 6x minus 6. That's our d square y dx squared. Now we put our values of 1 over here and of minus 3 over here. So when we put 1, when x is 1, we have minus 6 into 1 minus 6, that's minus 6 minus 6, that's minus 12. And since minus 12 is less than 0, the coordinates 1, 32 is a maximum because it's less than 0. And again, it's not minus 12 that's max, it's the coordinates 1, 32, because that's the x value of that coordinate is what we used. And then when x is minus 3, when x is equal to minus 3, we have minus 6, minus 3, minus 6. That's positive 18, because the minus and minus become positive, minus 6, and that's 12. And 12 is greater than 0. That means the coordinate minus 3, 0 is a minimum. It's a minimum. And what exactly does maximum minimum mean in this case is simply when there's a graph. Let's say this graph looks something like this. The minimum point is simply the turning point that's below the graph at a point, and the maximum is simply the part where it's above the graph most of the time, or above the other stationary point. So if this, we can say that this stationary point is above this one, hence this is the maximum. this stationary point is below this one, so hence this is the minimum. That's how another way we can differentiate it. Right, on to the next example. This one says the curve y equals x cubed plus px squared plus 2 has a stationary point when x is equal to 4. Okay, good to know. Find the value of the constant p, okay, and determine whether the stationary point is a maximum or minimum point. Right, we have our equation of the curve to be y equals to x cubed plus px squared plus 2, and it says it has a stationary point when x is 4. First things first, let's try and differentiate our y. This would be dy dx equals to 3x squared plus 2px. Now it said that it has a stationary point. That means the stationary point is present, so it's safe to say that 3x squared plus 2px is equal to 0. And it said it has a stationary point when x is 4. So all you do is simply substitute the x to be 4 in this equation. We would have 3 into 4 squared plus 2p into 4 equals 0. There should be 48 plus 8p equals 0. And solving for p, our p would be minus 6, because this would go to the other end, become minus 48, and divided by 8 would be minus 6. So our p is minus 6. So if you rewrite our dy dx now, our dy dx is 3x squared minus 12x, because 2 times minus 6 would give you minus 12. Now, the second part of the question said determine whether the stationary point is a maximum or a minimum. And we need to determine, and we know that our x value that we were using is 4. So let's get our second derivative first. So d squared y over dx squared would give you 6x minus 12. And substituting the value 4 into d squared y dx squared, this would be 6 into 4 minus 12, that's 24 minus 12, which is 12, and this is greater than 0, and hence it is a minimum point. When x is 4, it is a minimum point when the x coordinate is 4. You can see in this question we didn't need to find our y coordinates to solve it, because it didn't ask for it, and if we needed we would have, but with the information provided by the question it was more than enough. And on to the final example of this video, and this is a challenge question. Challenge question. So please do pause the video and have a go at this by yourself, and then resume the video to see if you are correct or incorrect. If you are incorrect, please take note of the mistake. And it's a big one too, 8 marks. So question says the curve y equals to 4x squared plus a over x plus 5 has a stationary point. Okay, good to know. It says find the value of the positive constant a given that the y coordinate of the stationary point is 32. In the previous question they gave us the x coordinate. This time they made it harder and gave us the y coordinate instead. First things first, as I can see, let's rewrite our equation, sorry. We can say that y is 4x squared plus ax to the power of minus 1 plus 5. Now the essence of rewriting is just that this helps us to differentiate. It's very hard to differentiate like as it is over here. You have to use a bunch of other rules. So rewriting like this helps us differentiate it. And if we indeed differentiate this dy dx, this would be 8x minus ax to the power of minus 2. That would be our dy dx. And we differentiated because it said that it has a stationary point. That means this is a curve that has a stationary point. And since it has a stationary point, it's safe to say that 8x minus ax to the power of minus 2 is equal to 0. Now we can rewrite this again in the form of fraction. We can say 8x minus a all over 2, sorry, not 2, x squared is equal to 0. And I can see that we can rearrange this to make a subject of the formula. So we can say minus a over x squared equals minus 8x. We know this is over 1, so cross multiply, we would have minus a to be minus 8x cubed. Minuses cancel, would just be a equals 8x cubed. Now this is not the final value for answer. I said to find the value for the constant. That's not a value, that's another expression. So we'll just keep that for now. Maybe we will need it later. From the other information given, it says that it said that given that the y coordinate of the stationary point is 32, we know that any stationary point, any x coordinate of the stationary point we insert it back into the equation for y. And this is saying that when we insert that back into that equation, we get y to be 32. So I can say that 32, because that's our y, is equal to 4x squared plus ax minus 1 plus 5. Because it said that the y coordinate is 32, that means when I put my stationary point, that x value stationary point over here, this would give me 32. And because we don't know our x, they've given us our y, because we need to know at least one thing. That's why our y is 32 here. Now collecting our like terms, we would have something like 27 equals to 4x squared plus ax to the power of minus 1. And we can rewrite this now to say 27 is equal to 4x squared plus a over x. Now you might be wondering, how do we get the value of a? And how do we get the value of x? Remember, we said that a is equal to 8x cubed. So putting that value in this equation here, we would have 27 equals to 4x squared plus 8x cubed over x. And now we can solve for x because there's only one unknown. So this x will cancel with 1x here. We will now have 27 equals to 4x squared plus 8x squared. This would be 12x squared equals 27. X squared would be 27 divided by 12, which should be let me just confirm real quick. 27 divided by 12, yep, 9 over 4. And x will now be the square root, plus minus again, square root of 9 over 4, and that should give me 3 over 2, but let's confirm. 9 over 4, yeah, gives me plus minus 3 root 2. Now, it said find the value of the positive constant a. We have two values for x, 3 over 2 and minus 3 over 2. Let's put both of them into our a over here, into our x over here. So we have a equals to 8 into 3 over 2 cube, or we have a equals to 8 into minus 3 over 2 cube. Doing our math, we know that this would give a is equal to 27, and the other one should give minus 27. Yeah, because it's just the signs are different, minus 27. Now both of these answers are correct. A is equal to 27, a is equal to minus 27. But which one do you use? You go back to the question and read in between the lines. It says find the value of the positive constant a. So which of the answers is positive? That's a is equal to 27. So this is not your answer, it's a is equal to 27. And that brings us to the end of this solution of this question, and indeed to the end of this video as well. So thank you for watching, guys. Hopefully you enjoy it. Please do not forget to perform an LSS, that is like, share and subscribe, and thank you for watching. Have a nice one.